Now we're going to take a look at how to use a scatter plot to interpret our data. So this data, we have the year after 2000, so note the the x-axis on this one. Instead of using 2000, 2002, 2004, which just gives you big numbers to work with and doesn't give you any difference in your line, we're just going to kind of shorten that up to year after 2000. And then notice our y-axis, population of Cottage Grove in thousands. So again, we're making our numbers smaller, a little bit easier to work with. So the first thing we're going to do is try and draw a line of fit through our data. Let's try and get the line on the data. So what you want to do when you're creating a line of fit is make sure that it goes through the center of the data as best you can. So you want to look at how many data values are below your line or how far away they are from your line versus how far the data values are above your line. And actually, I think I probably started my line in not quite the right spot, so I'm going to move this a little bit and tilt this down so that I have my line a little bit better through the center of the data. You can see I've got 3 data values above the line, one of which, this one right here, is quite a bit above the line in comparison to the other ones. So the fact that I have a few more data values below the line kind of balances because the ones below the line are closer to the line than that one that's a bit above it. All right, so that's our line of fit. Now we're going to write an equation. So to write an equation of a line, you need 2 points. So it looks to me like the ordered pair 4, 34 is on my line, and 10, 36 it looks like. So I'm going to use these 2 ordered pairs to write an equation of my line. Now, they don't actually have to be data values, but if you have a list of data values, it's a little bit easier to use an exact data value. But the main thing to remember is that the 2 points have to be on your line. So the first thing we do when we write the equation of a line, remember, is find the slope. Change in y over change in x. So my y coordinates are 36 and 34. And my x coordinates are 10 and 4. So I get a slope of 2, 6, which simplifies to 1/3. Once I have my slope, I use my point slope form of a line. So if you don't remember what that one is, where you take one of your 2 data values, or ordered pairs, and put that in for the x1 and y1. So our slope is 1/3. I'm going to use 434 because the numbers are smaller. So the -4 goes inside the asylum. Remember, it's the opposite. And then outside is the +34. So to finish solving to get this in slope-intercept form, we're going to distribute our 1/3. And then combining our like terms. So I rewrote the 4/3 as a mixed number, 1 and 1/3, and subtracted that from 3/4 to get my y-intercept, the 32 and 2/3. And finally, we're going to use this equation to predict the population in 2025. So here's where it's important to remember what the x and the y values represented. So remember, we talked about our x values were year after 2000. So when we're given the year 2025, we know that it's 25 years after 2000. And that's our x value. So we're going to substitute 25 into our equation for x. A third of 25 is 8 and 1/3. And 8 plus 32 is 40. 1/3 plus 2/3 is 1. So we have 41,000 because when we look at our scatter plot, the y-axis was population in thousands. So we can add that 1,000 onto our answer. And of course, we always label our answer, 41,000 people. All right, this last piece of information is talking about causation. So remember, causation is when one data value changes, what happens with the other data value. So first we're going to figure out whether the data would have a positive, negative, or no correlation, and then decide if that relationship is causal. So our first example, we're at a sandwich shop, and we want to think about the amount of turkey sold versus the amount of ham sold. So my first thought is people are either ordering turkey or ham. They're not typically going to order both. So the more turkey sold would make me think there would be less ham sold. So I believe this would be a negative correlation. And I also believe that it would be causal because, again, typically you don't get both turkey and ham. There might be a few people that do, but the majority of people would order one or the other. So ordering turkey would cause less ham to be sold. All right, second example, a car's speed and its stopping distance. So if we think about the faster you're going, the longer it takes you to stop. So they're both increasing together, so this is a positive relationship. And again, this is causal. The faster you go causes your stopping distance to increase. Our last one, GPA and amount of TV watched per week. Well, the higher your GPA, you're probably watching less TV. So I would say that this is a negative relationship. And I would say that this is not causal. Your high GPA does not cause you to watch less TV. And here are a couple of U-Try questions for you.